we're going to be talking about how to solve differential equations using separation of variables and also solving differential equations using slope fields today. All right, so without further ado, what is separation of variables? Well, it's a way of integrating differential equations which are derivatives. Okay, and sometimes when you have a differential equation, it's not just made up of one variable, but it's made of different variables or two variables. Usually, sometimes that is going to be x and y, or t and t and y, or whatever the case may be. And there are 4 easy steps on how to do this. We're going to do what's called separation of variables. We're going to integrate, then we're going to solve for c, and then we're going to find the solution. So, without further ado, let's try this out. Here we go. We're going to separate variables on this, which is essentially like a reverse implicit differentiation. Now, when you have this differential equation, which is dy dx. And here we have a differential equation, which is y plus x, and then we have x plus 2. Notice how we have an expression with y and an expression with x. Well, we can't integrate these because there are 2 different variables, and we only can integrate one at a time. So what we're going to do is we want to make sure that we get the y's with the dy and the x with the dx. So in order to solve this, we're going to multiply both sides by dx. When you do that, the dx's will cancel out, and then we're left with dy equals the quantity y plus 4. Sorry, not y plus 4, y plus 5. And you have x plus 2. Dx. Now from here, we want to make sure that we get our x's with the dx and our y's with the dy. Now, how do you get y by itself? Well, we're going to divide y plus 5 to the other side. And so now we have this expression, x plus 2 dx. That's what we call right here, getting the y's with itself and the x's with themselves. This is what's known as separation of variables. So now from here, we're actually going to solve this equation. So I'm going to change my thing. So now we're going to integrate both sides. Now we're going to integrate this first side, we'll integrate the x side. So we have integral of x is x squared over 2. And maybe you can pause this and do it yourself to see if you get it. And then we have 2x. And then we're going to add a plus c. I always add the plus c to one side. Now, we're going to integrate both sides because we're going to solve for the y equals the x, okay? You only need to solve for, you only need one c because c minus c is c, and so on and so forth. But now we're going to integrate this side. Now, this side we can integrate. Okay, notice that we have y plus 5. We could use substitution, but you may realize that this is an easy one to do. This is going to be a natural log because we have a power of 1 here. So this is going to be the natural log of y plus 5. Okay, y plus 5. Now from here, okay, that is going to be our integral. Okay, if you're wondering why that is, okay, just going to show you real quick. If we had this, we have the integral of 1 over y plus 5 dy. We would take u is equal to y plus 5. Du is going to equal du dx, or du dy, that is. We're going to have 1 dy. And so if I put everything back in there, we're going to have the integral of du over u, which is equal to the natural log of u, which is y plus 5. And that's why we have our answer right there. Okay, so just sharing that with you. Now, remember our c, okay? Remember our c? We don't need to put another c over here once again because when you add the c's together, they just become c again. So we only need one universal constant when we have that. Okay, so that's the second step. So the first step, separation of variables. Second step is we're going to integrate. The next thing is remember the c. Remember c, all right, plus c. And you can also solve for c as well if you want to. All right, sometimes but if we have an initial condition, but we don't. All right. And then the final step is now we need to solve for y, or solve for a dependent variable. Solve for dependent variable. Okay. So to solve for this dependent variable, I'm going to change my color right here. We're going to then e both sides in this case because we want to get y by itself. All right, we get y by itself. So we're going to have e. Now when I do that, these will cancel out, and then I'm left with is y plus 5, and that's going to equal e to the x squared over 2 power plus, all right, 2x power plus c power. We now want to solve for y, so I'm going to get y by itself. So I'm going to subtract 5 both sides. So I'm going to have negative 5, all right, plus e to the x squared over 2, all right, plus 2x plus c. All right. This would be an appropriate answer. That would be fine. At times, you want to maybe get this constant, all right, by itself, all right, but I'm just going to leave that as my answer, and that would be our solution to solving this differential equation, all right? That's what we got. We're going to try another one now, okay? And so right here, what we got is I'm going to solve this differential equation, okay? So the first thing is we're going to separate variables, call it SV, all right, SV. This one's a little bit different. Maybe you can pause it and try it yourself. All right. First thing is we get dy. And I'm going to put my dx on the other side. So we have cosine of x. We have e to the y plus sine of x. I'm going to have dx right there. Now from here, this is where it gets tricky. I got a y up here. So how can we separate that? Well, you're going to use a little bit of properties of exponents. And what you know is that when you adding to exponents, the same thing as multiplying. So you're going to have e to the y times e to the sine of x dx. That's the key right there, my friends. All right, because now here we can see that we have my y, and I'm going to divide that to the other side. So I'm going to have dy over e to the y. And then I'm going to have cosine of x, e to the sine of x, dx. All right. And this is where we just separated variables. Now we're good. And now we're going to do my second step, which is integrate. All right. And so we're going to integrate. So to integrate this, we want to rearrange this. So when you're integrating, it's not going to be natural log. I want to bring this to the top. So I'm going to write it as e to the negative y dy. All right, so we got to do some algebra. This side, all right, we're going to use u substitution. And I'm going to pick my u to be sine of x. That's right there inside there. Because the derivative of sine of x, derivative of sine of x is going to give me cosine of x, which just so happens to be what I'm left over with. And so I'm going to have the integral of e to the u, all right, du. So let's finish this off right here. So I'm going to integrate this puppy. And so when I have this is going to be negative e to the negative y equals e to the u. What is u? U is sine of x. Now we're going to go plus c. So don't forget your c, all right? Plus c. I'll put that in purple. Plus c right there. And that's what you want to have. Make sure you have your plus c, and then you solve for it if you need to. All right. Now from here, we want to solve for y, all right? Solve for y, okay? So solve for y. Why? Because we want to get y by itself, because we're solving for the differential equation, all right? Getting y by itself. So we're going to divide by negative. So we have negative y, or e to the y, negative y. We have negative e to the sine of x. The negative distributed here just keeps it as plus c, so that doesn't change. From here, we want to now get rid of this. We're going to natural log both sides. So when we natural log, all right, natural log of e to the negative y, we'll have natural log, put absolute values there, all right, of e to the sine of x plus c. Now, I know some of you are probably saying, well, Mr. Gutschok, all right, why is there, can we have a negative inside the natural log? Yes, you can have a negative because it will be positive because of the absolute value. All right, but it will work out, okay? From here, we're going to have negative y, because these will cancel out. Negative y equals natural log of the quantity e to the negative e to the sine of x plus c. And then we have opposite negative, so we have y equals, all right, negative natural log of negative e to the sine of x plus c. There, my friends, is your solution for this particular differential equation. So solving differential equations, you need to begin by separating the variables, and then you're going to solve it like so. All right, integrate it from your c, solve for y or the dependent variable, and go from there. Okay, well, I'm going to stop this video, so we're going to do some more with solving differential equations, and then we'll go into slope fields for the next one. All right.